Good day, everyone. Today, I and my group will be presenting about LearnHub with our slogan Education Without Borders. So, this is our final proposal for human computer interaction. So, our app is a comprehensive project based learning PBL initiative designed to democratize education by integrating artificial intelligence, extended reality, and inclusive digital environments into a unified platform. So, our vision and mission. So, our vision for this app is to create an education system without borders and barriers, ensuring every individual has equal access to quality learning resources irrespective of physical ability, location, or language. So a person can be disabled or normal and still use our app. So our mission is to design an innovative technology-driven learning platform using all the futuristic help such as AI, XR, and cloud computing. So we aim to address educational inequality by providing practical, cognitive, and collaborative resources that adapt to individual learning paces. So the problem defined here, a systematic inequalities hamper the advancements of SDG 4. Current system rely on a rigid one-size-fits-all pedagogical approach. That means it doesn't tailor to everyone. It's just everyone uses the same thing. So the lack of practical access here. 68.8% of surveyed learners report an absence of hands-on learning environment. So the support deficit, 56.3% struggle with receiving no immediate academic assistance. And the exclusion is marginalized students, motor impaired learners, and non-native speakers are disproportionately isolated. So our proposed scenario and target audience. So our target audience here is mainly students, working adults, vocational learners, remote rural communities, individuals with physical disabilities, and non-native language speakers across the globe. So we are just not looking into Malaysia, but we are looking across the globe to help everyone that is needed, everyone that needs our help. So our scenario analysis is about Mr. Lucas. So Lucas is a vocational student in a remote village with unreliable internet, which unreliable internet, we all know how it feels. It's really annoying. So Lucas is struggling with passive PDF modules in a foreign language. So he logs into LearnHub's progressive web app PWA, and he utilizes the multilingual toggle to switch the interface. Using the voice to ask commands, he opens the XR lab to practice a 3D circuit simulation. When stuck, he queries the floating AI virtual tutor for Socratic hints, all supported uninterrupted by the offline briefcase. So this helps him even though he has a very bad internet connection. So, validating the solutions, this is from our survey findings. So, lack of practical and hands-on learning is 68.8%, while no instant help when questioning is 56.3%. As you can see, both of these is more than half. And poor internet boring lessons is 43.8%, and language difficulty is 34.4%. So, the data derived from our primary questionnaire highlights the urgent demand for immersive simulation, XR labs, immediate real-time support, AI virtual tutor, and accessible delivery mechanism.
So I'll be talking about solutions and innovation pillars. First of all, we have AI virtual tutor. Then we have XR laboratory and interactive cinema. So an AI virtual tutor, it's always free for whenever you want, and you can talk and it'll give you feedback, live feedback. And then the XR laboratory, it replaces passive readings with interactive, risk-free web XR experiments. So this one, you can safely build physical skills digitally using drag and drop mechanics and an AR object scanner. For the interactive cinema, we convert passive streaming into an active cognitive task. Hotspot enable video learning overlays, touch responsive markers, and meet video checkpoints quizzes with instant feedbacks loops to verify comprehension. Then the user journey and storyboards for this is Alex sessions. So it was a seamless entry. Alex uses voice navigation microphone icon in the minimalist center hall to bypass complex menus. So starting with open the laboratory, setting the open the laboratory. Then interactive video in the cinema as networking video pauses automatically to present a mid-video checkpoint quiz, ensuring active cognitive engagement over passive viewing. And then we have AI intervention. During a WebGL circuit assembly, Alex can confuse his queries of floating AI virtual tutor to receiving an instant context-aware explanation to proceed. And lastly, gamified progress. Upon completion, 150 XP is awarded. Alex view his skill tree in the arcade, visually mapping his cognitive development and earning the badges. So this is his journey. So where he uses all these parts and everything. And then we have social impact and future outlook. Democratizing SGD 4. LearnHub actively builds measurable social equity by providing equal access to quality resources. It leverages voice to task commands for the physically disabled, offline caching for the digital divided, and multilingual matrices for marginalized non-native speakers. For the future enhancements, we are planning for mesh networking, unified dashboards, and native compilations. For the mesh networking, peer-to-peer data syncing for fully disconnected environment without cellular networks. And unified dashboards trying to advanced analytics for educators to track students' cognitive milestones securely, and native compilations optimize multi-device builds tailored for advanced mixed reality hardwares. And this is done all for my part. Next is.
Good morning. My name is Adwin Raj, and I'm going to be presenting about System Architecture Overview. The foundation of our platform is a SPA, Single Page Application Engine. It operates on a client-side component-driven model using React 18 and Vite. This means everything renders locally in the user browser, completely bypassing server latency. Within this engine, React Router orchestrates instant navigation between modules, while our global state context dynamically synchronizes gamification data and multi-language translation. Because we have this robust locally processed SPA foundation, we can seamlessly integrate three advanced technologies directly into the browser. First is AI. The SPA powers a simulated LLM matrix that delivers persistent context-aware Socratic hints in real time. Second, extended reality XR/AR. We leverage the web architecture to build safe web accessible AR simulation utilizing mobile camera feed and drag and drop mechanics. Finally, PWA and cloud edge caching. We upgrade the SPA into a progressive web app by serializing the data into local browser storage, what we call the offline briefcase. We bypass restrictive internet dependency, allowing platform to work entirely offline. Thank you.
My name is Yusen Hao. I will talk about Create Info, which is about the project scope and main functions. LearnHub is an early test version of a learning website. It shows the main pages and the functions, but it is not a complete final system. This slide shows 5 main functions. Alpha01 lets users move from the center hall to different learning areas. Alpha02 lets users choose learning materials for the briefcase, but the materials are not saved after the browser is closed. Alpha03 is an interactive video designed with hotspot and short quizzes. Alpha05 is a workshop where users drag and drop items to complete a task. Alpha10 lets users move between pages by walking through the web space API. In the version, we focus on the website design and user interaction. Accounts, cloud storage, live AI, and real camera scanning are not included yet. Thank you.
Hi, I'm Hui Heng, and this is our prototype called Learning Hub. This is our main page. It consists of 5 functions with a noise navigation on the bottom right with a multi-language tool to switch the language. So first, this is our library page. It acts as our comprehensive digital repository. It houses extensive and reading milestone for foundational research and self-paced study. Next is Cinema. It's a dedicated video learning space where students can engage with documentaries and lectures utilizing interactive hotspots for learning. Up next is our laboratory page. So this is where the student can conduct hand-on and simulated STEM experiments, and it features an integrated AI feature tutor that provides real-time guidance and answers questions instantly. This is the stage page. It's built for social and collaborative learning. It acts as a peer discussion area to practice presentation, communication, and soft skill. And lastly, this is our arcade page. It focuses on cognitive development. It utilizes gamified learning experience to make complex problem solving both fun and highly engaging. So, crucially, to ensure that no student is left behind, the entire hub features a built-in voice navigation for hands-free accessibility, and Global EDU is a complete inclusive ecosystem for the future of learning. In conclusion, Global EDU is more than just a virtual space. It is a comprehensive ecosystem designed to make SDG 4 a reality. By combining these 5 distinct learning zones with hands-free accessibility, we are building a borderless, inclusive classroom for the future. Thank you.